So in our cluster, we proposed two little short focus. The first one, it is to highlight how the Risk Institute allowed us to initiate industrial chair and about the aging of hydromechanical structure, and particularly the chair called Medelia. It means in Latin take care, about probabilistic fatigue of hydromechanical structure. And three very short items to see to explain why it is a hot issue, particularly around Grenoble, and some illustration just in the next slide. Aging hydromechanical structures. What are the why it is a hot issue, particularly for engineers and for our operator in France and in the world? It is that we have many hydraulic works that are very old, several decades, more than 1 century sometimes. You have example in pictures, log gates. We have several thousand kilometers of rivers in France with such infrastructures. We have component of hydro power plants, for example, runners of turbines or ball valve. You have this example in front of you, and they have worked for decades, but instead of changing altogether, we have to take into account an increased number of cycling because of energy demand, of optimization, and because all these infrastructures are old, we have also a lack of data. How to account for fatigue, how to better estimate residual useful life. So this is a hot issue, particularly around Grenoble, because we have main major operators in France and I would say in the world around Grenoble. We have EDF, you probably know, the main electricity supplier in France, but also the main hydroelectricity supplier in Europe. CNR for Compagnie Nationale du Rhône. This is a major operator along the Rhône River. It's 1/4 of hydroelectricity in France, I think. And we have also large companies implanted in Grenoble for less than 1 century. Artelia, which is a group in the world with, I think, more than 1 billion euro sales, which is implanted at all these actors, operators, stakeholders are interested by our research, and it's why we were consulted to help them, and it is because of a cross-disciplinary project that with Christophe BERENGUER we decided to go and to try, because it was very challenging, because this team never experienced research with university. And one of the results, this is an article, damage due to start-stop cycle of turbine runners under high cycle fatigue, with industrial data from the company, with a problem of instrumentation, with problem of mechanics from data, and because we were two complementary laboratory, it was possible and it was successful, and we provided the original methodology to estimate relative damage of runners and cost indicator of start and stop phases of runners. That was really strategic for the company. So because of this experience, it was possible to accept another challenge with this large company called Artelia, with particularly an engineering company called Spretec, to help them to deal with this fatigue problem of hydromechanical structures. And it began just this year. It is with another colleague, Rafael Esteves, that couldn't be there. It is also from another laboratory, is specialized in fracture mechanics, and I am more specialized in the reliability analysis at the scale of structures. And our aim is to propose strategies to better characterize remaining useful life of welded steel structure more particularly. And you have example of structures that can be studied in this company using experimental measurements, using finite element modeling at different scales. And the challenge it is to account for particularly this welded connection of, for example, log gates that sometimes are not only old but with beginning of fracture. So we have to change. We have to plan maintenance to account for different uncertainties about material, about loading history, about geometry, boundary conditions, and we have some data also from CNR, another operator that is very interesting in this topic, and we are all together develop some strategy about probabilistic fatigue analysis using finite element model that I show you with a stochastic approach. So very practically, for example, for a log gate, we can do the engineering study and focus on some assemblies, some connection that can be more stressed and with a probability of damage that can be higher from one or the another. But it's very difficult for the operator to know if they have to change in priority because their estimations are too approximated. So it is why our collaboration between two different laboratories, the colleague specialized in fracture mechanics at the scale of connection, me rather focused on stochastic finite element modeling, we are able to produce two-scale stochastic finite element calculations. We are producing new indicators. I'm already satisfied of results we have now to prove, to publish it, but it's ongoing work. And for example, a typical result, it can be a cumulative distribution function for all people working on probabilistic approach. It's very usual, but these cumulative distribution functions have to be to account for both fracture mechanics estimates and also stochastic finite element studies because we cannot deduce everything from a too simple modeling at a whole scale of a structure. We have to invent, to be creative. And this is because of the strong demand from engineers and operators that we contribute like that to care for aging infrastructure. It's the name of the chair, Medelia. So we have other PhD in the near future in the context of this chair, but also in the context of a cluster. And particularly, we would like also to focus about a European working group called ESReDA Resilience Assessment of Critical Infrastructure. And I propose my colleague to talk a few minutes about that.
Okay, thank you, Julien. Good morning. So I'm going to give just some information about a collaborative activity at the European level that we have in the cluster, and we have been involved in this kind of activity since the beginning of our cooperation within the RISK Institute. So this activity is made in the framework of the ESReDA. ESReDA is the European Safety and Reliability Data Association. It's a scientific society more focused on industrial and technological risk, but with a more or less within this framework multidisciplinary approach as far as it can be on industrial risk. Okay, and we have been involved in the previous working group on resilience of infrastructure networks. We have organized a seminar, a two-day seminar with more than 60 participants from all over Europe on this topic in May 2022, I think. And then we are We have been taking the lead on the new project group funded by ESReDA on the resilience assessment of critical infrastructure. So this is not really a big research project as Horizon 2020 could be. It's more a collaborative place where people can exchange and share good practice on our methodologies. One of the deliverables of this activity is to produce a technical reference, a book, just like we did for the previous project group. This book has been published by the European Union through the GRC publishing entity. And our aim is also to disseminate the state-of-the-art results and the next avenues for research on the topic among the ESReDA member and in several conferences. Okay, I think we don't have that much time, so I'm just recalling in this slide the importance of resilience for critical infrastructure that has become an important research topic, but also that has been transferred to the policy. For example, with the new directive that went in force in January 2023, naming explicitly resilience in its title, replacing the previous directive on critical infrastructure. And we are going to focus on resilience application for different kind of critical infrastructures, each member of the group coming with its own knowledge on different kind of infrastructures and sharing proven methodology and seeing how we can transfer this to other kind of infrastructures. Okay, so some of the topics that we have already identified could be, for example, analyzing complex interacting system, coupling or developing the complete chain from modeling to decision aiding and applied on the real example, so going from theory to practice on this modeling to decision chain, and moving from risk to resilience, trying to identify the key differences and introducing one of the big problem of different time scales within these problems, and how to use, for example, ramps approaches widely used in the industrial sector to go to resilience when they are coupled with natural hazard, just like in NatTech issues. Okay, so this is just the management of the group. We are two from the cluster involved in the management of this group, and we plan activity mainly two meetings per year, and then sharing and proposing session then to the main conference in the field, and of course writing this book on the 3 years horizon of the project. Okay, thank you.